In this video, we will use factorial and double factorial to generate the Taylor-Maclaurin series sum of hyperbolic cosine. We begin with the dataset of the hyperbolic cosine. Array formula: hyperbolic cosine of the x values from -2 to +2. And we chart this. Insert chart. And we use scatter chart. Use row 1 as headers. Customize the series. Show the trend line. The type polynomial. The degree 8. For the label, use the equation. For the legend, position at the bottom. Here's the trend line and polynomial of hyperbolic cosine. Next, we calculate the Taylor-Maclaurin series sum expansion of hyperbolic cosine, which is the summation of a times x to the power 2n, where n is from 0 to infinity. So starting from 0 up to infinity. 16 is good enough. And the value of a can be a1 or a2. a1 if it is factorial. So array formula: 1 over that's 1 over factorial 2 times n. And enter. Now the double factorial, which is equal to array formula: 1 over. Now there are two parts. The first part, factorial fact double, 2 times n. That's the first part. The second part, double factorial, 2 times n minus 1. And enter. These values are exactly the same. We'll calculate this first part. So if n equals 0, then 1. Otherwise, calculate. Now they're exactly the same. We now continue with the expansion. So our formula: series sum of the x values raised to the power 2n, where 2n starts from at n equals 0. So start from 0. Then followed by n equals 1, that's 2, 4, 6, so the interval is 2. And the coefficient, you can use double factorial or the factorial. Start with the double factorial. So here you have the equation. There's no polynomial, so we added the chart and show the trend line. Customize series, show the trend line, the type polynomial, the degree 8, and for the label, use the equation. The equations are exactly the same. We calculate this polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. It is equal to transpose of the values 0 to 8. Now the elements of the matrix. The elements of the matrix is array formula of the x values raised to the power 0 to 8. Enter. Now we can use LINEST. LINEST of the functions theta y, that's hyperbolic cosine, and theta x. Next, the expansion. LINEST, theta y, and theta x. So these are our polynomial regression coefficients. Let's compare that with the chart. Coefficient of x to the 0, 1. Coefficient of x, 0. Coefficient of x squared, zero point 0.5. Coefficient of x cubed, 0. Coefficient of x to the 4th, 0.0417. Coefficient of x to the 5th, 0. Coefficient of x to the 6th, 1.38 times 10 to the minus 3. Coefficient of x to the 7th, 0. Coefficient of x to the 8th, 2.7 times 10 to the minus 5th, 5. That's because we're using here, in the expansion, we're using the double factorial. Suppose we use the factorial. Let's use the factorial. And enter. You still get the same polynomial regression coefficients. The polynomials are still the same, the trend line is still the same, and the datasets, they're still the same. This completes the use of double factorial and factorial that generate the Taylor-Maclaurin series sum of hyperbolic cosine and its linear Linus polynomial